Hello and welcome back. Today we are going to have a look at the application of MMC concepts. We often talk about MMC and LMC conditions, but it is very important to understand why we use the MMC concept and where it is applied. The purpose of using MMC is not just theoretical, it is mainly driven by assembly and functional requirements. The MMC concept is primarily applied to mating features, such as holes and pins, to ensure proper assembly between parts. In most practical situations, our main concern is whether the parts will assemble successfully, especially when both parts are at their worst case size conditions. That is where the MMC concept becomes extremely useful. The MMC concept is widely used to guarantee assembly, even when the features of size are at their maximum material condition. The parts are produced at the extreme ends of their tolerances. By applying geometric tolerances at MMC, we gain an important advantage, which is the bonus tolerance. This more flexibility in manufacturing. It helps accommodate real-world variations such as tilt, misalignment, and form error. Because of this, MMC is most commonly used in clearance fit applications, where ensuring assembly is critical. Now let's look at an example. We have a pin with a diameter of 10 plus or minus 0.1 mm, an orientation control of 0.05 at MMC relative to datum A. In this case, the virtual condition of the pin is 10.15 mm. This virtual condition represents the worst case boundary that ensures assembly with the mating hole. In real manufacturing, the pin may not be perfectly straight. In other words, the axis of the pin may be tilted. The orientation tolerance of 0.05 at MMC means that when the pin is at its MMC size, the allowed tilt is limited to 0.05. The pin must still fit within the 10.15 mm virtual condition boundary. However, as the pin size moves away from MMC toward LMC, the pin contains less material. This means that there is additional tolerance available as bonus tolerance. This extra tolerance allows more tilt or deviation. This directly helps the assembly because the pin can still fit into the mating hole, even with increased geometric variation. Now, when we consider the LMC condition, the feature has more clearance, which gives more room for geometric deviation. As a result, the available bonus tolerance increases. This added tolerance helps ensure that the part fits into its mating counterpart, as well as maintaining proper function. This is why the MMC concept is one of the most powerful and widely used tools in GD&T, especially when assembly and functional fit are the primary concerns.